multiple choice questions. So for anyone just joining us, who might have been absent today, especially people in period 6 that are leaving early, we did these in our workspace. When the kids got logged into AP Classroom, there is an announcement in your Google Classroom. You should use your College Board account that you've used for ACT, SAT, previous AP classes. And then there is already an assignment in there. I'm just regurgitating it for the video real fast. It's due next Wednesday by 11:45 p.m. It's practice multiple choice. Do your best, but I'm not allowed by College Board, and neither are any of your other AP teachers, on AP Classroom alone to assign letter grades. We're only allowed to say, yeah, they tried it. But what is the purpose of these practice multiple choice? To learn, right? And to have an AP testing experience and to see some more practice problems, which are always good in math, to get some extra exposure. Now, what if you get stuck on a practice problem? You do your best, you get it wrong, and I don't know why the answer is what it is. What could you do to bring it to class and ask me?
Write it down. You
could write it down, or you could, come on, we live in a technological age.
Email.
You could screenshot it and post it to Google Classroom and be like, did anybody figure out how to do this? Or I guess you could wait until you come and then do it with me. You're not stuck. You don't have to be like, oh, well, didn't get that one. Let's move on. You can screenshot it. You can snip it if you have like an actual computer. And you can, I mean, if you really want to, Kyle, you could write it all down. In your workspace. Hey, you could use your workspace on the online assessments, right? Because then you have scratch paper and you're keeping track of it, and then we can come to class like after it's due, which in this case is due right before the test. But the test is from me, the test is from the chapter, the test is on content that we've covered. So the AP practice multiple choice is helpful, but it's not necessarily exactly what the test is going to look like. Just all things to keep going on, to keep in your head as you're doing these things. Forever cards, study them this weekend. Forever quiz is next Wednesday, I think. All right, so as you guys did number 79, you were looking for vertical asymptotes, which was like a huge section in homework. So hopefully you went checking out this dude and you were trying to factor him, right? Mm-hmm. And as you were factoring him, the denominator, that's where problems occur. You were seeing that there's an x plus 2, x minus 2 up here, so thinking maybe there's a whole or shared 0. If you were really cool and you learned guess and check back in the day, maybe you did like a 2x and a 2, and you figured out if you put a 2 here and a 1 here, you would have a 4 and a 1, which if you throw in negatives can make -5. That could be fun. But if you're one of those who does it in an old-fashioned way, hopefully you would have done A times C, looking for that middle term of -5, realizing -4 and -1 is the way to go. And if you want to use that magical trick we saw yesterday, you would make a star with a line above that. You would take the leading coefficient of 2 and throw it in, and then you would reduce whatever you have left. The top one is the x term, the bottom term is the constant term. 1x minus 2 and 2x minus 1. What? Gorgeous. No grouping necessary. Isn't that cool? I literally just learned it last year. I was like, what? Now, I'm not sure exactly how much comprehension you have of what's really going on, but hey, it works. 2 and minus and plus, and we can reduce. So y was the only vertical asymptote, positive 1/2, because he was a whole. Because he was a whole. He was removable. He wasn't a vertical asymptote. If you're done, Gavin, turn on. Thanks, bud. Does that make sense?
Mm-hmm.
Now, where could people have gotten stuck? Factoring wrong?
Yes.
But if they factored wrong, couldn't you have plugged in and seen if it was a 0 or not if you weren't sure on your factoring? Would have been messy. Would have taken forever, but you couldn't. And then, wait, B, couldn't you have plugged in both? Now, you did good factoring, right? But you needed to plug in and see if it's a number over 0 or 0 over 0, but factoring makes that job a lot easier, because if it can be removed, it's a whole, so forget it. Is that cool?
Yes.
So letter A. Number 80, we're taking the limit as what? What are you taking the, I don't even, it's secant. It's okay, who's secant?
1 over cosine.
So it's 1 over cosine of pi, x over 2. Is that good or bad that we're going to -1 of cosine of pi x over 2? If we're going to -1, now I know, it's below, but forget that. It doesn't matter if there's not a problem, right? So plug it in. What's cosine of -pi over 2? Isn't it a 0? So isn't that 1 over 0? Now, this one's going to be -2, but guys, 1 over 0, what should that tell us? There's some sort of plus or minus infinity, check the sign. How do we check the sign? We think of what's something a little bit to the left of -1?
-1.1.
-1.1. So if we do, now, I know, it's unit circle, you're like, oh, but stop. Wouldn't it be a little more negative, -1.1? So what would happen if you went a little more negative? What quadrant are you in?
Third.
You see it?
Second.
So if you go a little more negative, you're in quadrant 3. If you're in quadrant 3, what is cosine's sign? It's negative. I mean, so is sine. They're both negative. So the nice thing is, to check the sign, well, I know that the sign is negative infinity. And guys, negative infinity minus 2 is still negative. Because if you're decreasing without bound and you're shifted down to whatever, I'm still decreasing without bound. So therefore, the final answer is, wow.
Obviously, this is okay.
Are you seeing it? The key was a number over 0, and then realizing coming from below is going to be, now careful, if you had come from the wrong direction, if you had thought that it was like -0.9, not that you should have been plugging it into your calculator, but you would have been in the 4th quadrant, and the 4th quadrant would have been a positive cosine, a positive infinity. And a positive infinity minus 2, a positive infinity shifted down to is still increasing without bounds. So the key won't take away from the infinite. Last one is number 81. Sorry, I've not been good at separating my work. Okay, number 81. The graph of the function is shown. X equals 1 is a vertical asymptote. I can see it, can't you? Y is a false. Wait, pause. What are we looking for? True. But in other questions, we look for false. So we have to be careful, right? But in this one, why is A going to be crossed off? Why is it false?
One's going positive, one's going negative.
So that means the limit does not exist because the two sides don't agree. The limit as x approaches 3 of f of x is 1. What? I mean, f of 3 is 1. F of 3 is 1, but is the limit?
No.
No. The limit does not exist.
Blasphemous.
I found it. Oh wait, no. We're looking for
Truth.
true statements.
Jesus came to tell the truth.
Be the truth. That's true. Coming back. Coming back. I just don't like this guy, so I'm ignoring him. The limit as, you guys do this too. The limit as x goes to 0 from above, 0 from above is 2. Okay, so that's 2. The limit as x approaches 3 from above is 2. Hey, that one's true. Dun, 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 dun. A-A-D. Yay! Got it. Why is this one false? You're coming from below, you're coming from above. As you come from below 3, is it a lower height than above 3? Oh no, it's switched. Above 3 is lower than below 3. I don't know if that was wrong. How many guys got at least 1 right? Be proud. Keep it up if you got 2 right. Give it back 3 right. Woo! 3 people got 3 right. Good job. All right, let's check homework. Let's check homework. So section 1.4 we already graded, but you might have questions on. Section 1.5 is what we need to grade right now. Section 1.5. Angelica, are we seeing Hamilton?
Yes.
Oh dear.
It's a TikTok now.
He's coming back to LA. At some point, right? Isn't it like the spring or something?
Yeah, me and my family flew out to
I'm not here for you.
I'm jealous. Remember Mrs. Choi went? Was it 2 years ago?
Mrs. Choi. Rip the legends. Wow.
Alright guys, number 2. Number 2, you're supposed to be analyzing the behavior near the vertical asymptote or something, aka limit below above.
Asymptote.
Do you want some? Can I share it with you? Yeah, I do.
Yes. Sorry. Limit from above is infinity. Limit from below is negative infinity.
Having brought some for the whole class.
No, haven't been. Just have it.
Are you serious?
Yeah. Sorry, Andrea.
Wait, were they for you?
No, she just wanted one.
Oh no, it's okay. It's okay.
You're welcome. All right, so whoop, whoop.
Abigail.
Mr. Chase always do that.
If you want a treat, don't worry. Krispy Kreme is for sale today by the Senior Cross Council. It's a little weird the pricing, but it's okay. Okay, so
The Che way.
above positive infinity, below negative infinity. Number 4, they agree and they're both positive infinity. Oh, just kidding. You're only coming from one side. That one lies. Because the limit would not exist. Number 6, coming from below is positive infinity. Coming from above is negative infinity. You might have switched them because of the negative in the top, because it flips it. Is that what happened?
No, I didn't.
This one's nice because they're both negative infinity. Yeah?
Yeah.
You guys see the difference, right? This one can be positive or negative, but as soon as you throw a squared in, it'll stay the same. That's kind of nice. Number 12 was up above. You might not have seen it. Did you guys have number 10? No. Okay. Number 12 was one of those nasty table ones. But long story short, from below was negative infinity. From above was positive infinity.
Wow, I didn't get
I think they were right and left. You got it.
Oh yeah. No.
Yeah, it's okay.
I put that.
Here's how the book did it too, right? I actually put words.
I don't know. I put words.
I think the book did, but as long as you realize what it looks like in math. I think it maths faster, but if you don't like that, that's fine. Number 20, did you guys already figure out that the limit is 12, which means there are no vertical asymptotes?
Yes.
Oh, and to 0 over 0 at 2. My bad. The limit is 12, the limit exists. That's what the book says. Like, hey, it's removable, but also couldn't you have factored it? And then we did that one almost together yesterday. What am I doing?
How did they factor?
Oh, well, it's a good question. You guys know how most of you have memorized that a squared minus b squared factors to be a plus b and a minus b?
Yeah.
There's also a form. Oh, no, I didn't want that.
That's fine.
Okay. There's also a formula that says if you have a cubed minus b cubed, it ends up being a, same, opposite,
Yeah, it would be good, yeah.
Is it AB?
yeah, and then always positive. There you go. Or you could do a cubed plus b cubed. I think it's same,
Plus calc
opposite,
C.
always positive. Mr. Crawford, you guys probably barely remember him.
I remember him.
Who?
Cool hair, played the guitar, Mr. Shaq's like best buddy.
Oh.
Coffee connoisseur and the holder of amazingly expensive pens.
I used to teach you that.
Yeah. And Bible. He taught some, I think, seniors now.
And he taught personal finance.
Oh yeah. He's the one that brought it on campus. He would have people memorize this with SOAP. Same, opposite, always positive. So with the difference of cubes, now you still have to remember the whole AB thing, but you're in CalcAB, maybe that'll help. You keep the sign the same, then the opposite, then the always positive, the same, the opposite, the always positive. But if worse comes to worse, couldn't you have just done a little and then you have 1, 0, 0, 8. Sorry, negative 8. You could have done a synthetic division because if you plug in 0 over 0, he goes in perfectly. So we could divide away this guy to see what's left. And when you do that, who's left? X squared plus 2x plus 1.
That is not what I got.
But, long story short, there's a whole lot of vertical asymptote, right? Long story short, there's a whole lot of vertical asymptote. Number 28 is a yes vertical asymptote. Did you guys use LN's basic graph? LN always has a vertical asymptote at the 0 of its argument because the domain says you, sir, have to stay greater than 0 because at the 0, negative 3, would be a vertical asymptote. So you didn't actually have to do any math. You could have just used the basic graph. Number 44 is negative infinity.
Oh, I didn't.
Do you guys see the minus? 1 over 0 is infinity. Check the sign. 0.1 is positive, but there's a minus. 6 minus positive infinity is negative infinity. Number 52 is 0. Because anything to the 0 power is 1, and sine of 0 is 0. 0 times 1 is 0. That was one where the side coming from the right did not matter at all. It was just the plug and chug. Number 56. Number 56. According to our limit properties. According to our limit properties. You can take the limit of each one, limit of the first minus limit of the second, and that's exactly what they did. The limit of the first was 1/2. The limit of the second was positive infinity, so 1/2 minus positive infinity is negative infinity. 62 is no. Oh, probably, but it's an odd.
Oh.
So if someone has the answer to 63, be like,
They weren't them.
It was an many possible.
oh, many possible answers to 63, so maybe that was hard. 56, yeah.
Well, you could, like, make it weird.
Wait, 63 was a, oh, I'm in the wrong section, I'm at 1.6. I was confused. 63, oh, it was sketching a graph. Okay, hold on, I like these ones. Beep, beep.
Why did you look like that?
Did I put them all up to the front? I did.
They matched the.
You should try nails.
Is this it? Write a rational function with the vertical asymptote to x equals 6 and x equals -2 with a 0 at. The book might even have not given you one, which is kind of lame. So Andrea, about 63, it's a good one for us to peek at because it was like many possible answers. I would have done it. Vertical asymptote. Rational function is a fraction. I need an x minus 6 to have a 6 be a 0. I need an x plus 2 to have a -2 be a 0. I need an x minus 3 on top to make the whole thing 0.
That's what I did too.
But if you want, you could have done, I don't know, like 2s and 5s. You could have like thrown extra stuff in if you
To
wanted.
the 18th power.
To the 18th power, sure. And then square rooted. And the 4th.
Thanks to Jade. Brad, do that.
Alright guys. Boop. Bloop. I would love to get into section 1.6 just a little bit, but I promised to go over homework questions with you guys from 1.4 or 1.5. Is there anything that you guys would like to see now?
I have a question.
Yeah.
You know that one where it was, what was it?
Wow.
As Adam's thinking of his question, anybody have a homework question for me to get ready? Kathleen.
Kathleen.
1.5, number 45. Adam, you ready yet?
Oh no, it's like a not homework.
No, I know. That's why I'm giving you time to verbalize.
I'll be ready.
You'll be ready in a second.
Yeah.
Okay, number 45. Number 44.
Sorry.
Sorry about that.
Did you say sorry?
When you guys plug in, you would get 6 minus 1 over 0, true?
Yeah.
Now remember, according to limit properties, we could technically take the limit as x goes to 0 positive of this guy, and then the limit as x goes to 0 positive of that guy. The limit of any constant is itself. So technically, I can actually, as soon as I see the number over 0, I can say, okay, but wait, I know the limit of any constant is the constant. What I need to figure out is this dude. So taking him off to the side. He's a number over 0. I need to do or think positive or negative infinity, check the sign. 0 coming from above would be a 0.1, right? Plugging in 0.1, I would end up with a positive over a positive. So that'd be a positive infinity. But when I plug it in context of the equation, 6, a set constant minus ever increasing values, is going to ever decrease. Yeah.
I figured you know.
Anything else we want to see in homework 1.5 or 1.4? I'm ready. I'm all ears, one foot, and a couple hands. You sure?
Oh.
Oh yeah, right.
It's all 1.4.
Okay, that's fine.
It was.
What number?
It was 101.
Oh, I was just there.
You don't have 101.
Oh wait, 102. Sorry.
Yeah, we did have 102. We have the most random conversations in this class.
Because for Halloween, or something.
Spooky season.
Spooky, scary skeleton.
No.
Yeah.
Oh my god.
Mariah, what are the directions? Oh, IBT, right?
Yeah.
Okay. IBT applies. For IBT to apply, F has to be continuous on the closed interval that's indicated, 5 halves to 4. Why am I going to say yes, even though there's a clear discontinuity at 1?
Because
At the interval.
This is 2.5 to 4. The clear discontinuity of the domain
Or that.
restriction is earlier. So it's fine here. It's not fine here, but it's fine here. Then I have to check for IBT if f of c, which is 6, is in between f of a and f of b. Now hold on, I don't know if f of a is lower or bigger. So I'm going to go ahead and just kind of ignore that for right now. I need to make sure he's between. So let's go ahead and see who f of a is. F of 5 halves, and then f of 4. Plugging in 4, that one's easy because it's 1620 over 3, which would be somewhere in the neighborhood of, it's okay, 6 2/3. A little bit more than 6. If I plug in 5 halves, which I did horribly the other day in period 6, we end up with 25 fourths plus 5 halves would be 10 fourths, which would be 35 fourths. P.S. Remember how a lot of us on our summer review quiz said 3 times 3 was 6? Or other silly mistakes? You gotta slow down a little bit. So I'm just doing it fast for sake of illustration. 5 halves minus 2 halves, 3 halves. Let's see, when we do this, these can reduce little denominators to be 2 and 1. The 2 pops down, we end up with 35 6, which is approximately 5 and, well, exactly 5 and 5 6. Nice thing is, does 6 fall between 5 and 5 6 and 6 2/3?
Yeah.
Yes. So therefore, IBT applies. And if IBT applies, then we go to that big old highlighted expression that says, cool, take the K and set it equal to the f of c. And this is where it gets a little confusing. Who is f of c? The function, oops, sorry. Just ignore that, it'll disappear right now. The function needs to be set equal to the 6. Then a few people got stuck who were in here chilling, but can't I multiply in pre-cal? One of the big things I tried to solidify in people's minds was, if you're stuck, just get rid of any division. So multiply that guy over, we get 6c minus 6c squared plus c. If I combine,
Wait.
yeah,
No. Just kidding.
but our brains don't always like it. Does that make sense? Then I have to factor and I end up with c minus 2, c minus 3, c equals 2 and 3, but why am I going to only say that the guaranteed one is 3? Because my theorem says there's at least one number in A to B, and only one in A to B is that guy. Does that make sense? Yeah.
I think yesterday when you put the answers up, it said something different though.
Oh, that's weird, but I have them right here. Let's go check. So section 1.4.
I don't know. I remember.
Okay, everything's mad at me. Hold on. Beep, beep. I don't like moving things. Says the function is continuous, non-removable.
I just marked it wrong.
Oh, there was a lot of work. C ended up being 3, but you might have seen the 6 and thought that was it.
Okay.
Yeah, it's really hard sometimes to find the answer. C equals 3.
So do you have to plug it back in normally, or you can just say C equals 3?
That was just their double checking that they've done it right. That's okay. Anything else from 1.4?
I just have a question on 102. Can you go back to the work?
Did I just show?
Yeah.
Sorry, it was messy. I was squishing it in.
So, oh no, never mind. No wait, could you pick out a negative C? That we get C minus 1. Negative C times C minus 1. I'm just trying to.
Here?
Yes. Well no, before you get rid of the division.
You could have, and it would have been 1 minus C, but normally we like binomials to be
I'll take out
variable
the
and
top.
constant.
Take out
But that would have been a plus 1. So if we pulled out a negative, this would be plus, but that would be negative.
well, if you take out a negative C on top.
This is how my brain sees it. I'm going to show you, but this is how my brain sees it, Kyle. I see that these have the same sign, and these have opposite signs. So no matter how I rearrange it, they're never going to match. But let me show you what happens. If you pull out a negative C, you would get negative C minus 1.
Okay.
See it?
Yeah.
So the problem is you have to, they still stay the same. So if you're like, I changed him, you're going to change him too. It's a good idea, but not helpful in this case. And your brain might have done it quickly and been like, yay, because you want it to match, but just because you want it doesn't mean it's always true. There's life lesson in there somewhere.
That's right there.
It's in there. Okay, 1415 questions, going once, going twice. Hey, some of you guys who are missing 0 period stamps, we're supposed to be up to September week 1, I think, right? Couldn't you maybe have some unresolved homework questions that you come in and ask me during lunch or after school and I give you a stamp for it? Or period 7, depending on your availability. Okay. So we don't have to be here Wednesday mornings, and we don't have to be in a really crazy, noisy, somewhat productive room to be doing math. You can come in after school or during lunch and get your questions answered your way. Yeah? Okay. All right, let's go ahead and go to section 1.6. What is the title of this dude? Limits at infinity, or the way that I like to think about them, which I guess is very technically incorrect because every textbook I've ever seen puts the word at. I like to think of 2. I like to think of limits to infinity. Because 2 makes more sense. You're going to infinity. Or to negative infinity. But what's moving in a limit as we go to something are the x values.
Yeah.
So limits at infinity, which I guess for limits they're trying to say you approach, and so you're kind of like arriving by taking a limit. So you're arriving at infinity, which is impossible in any other context besides limits. I don't know. I guess they're trying to be snazzy. But oh, funny thing, yesterday with the negative 3,000 thing. Period 6 didn't bring up Marvel at all. I was a little disappointed. I probably should have brought it up, but I was like, oh well. Life's too short. You guys are just better? Okay. We can say that. We're going to infinity and beyond, or to negative infinity and beyond. Remember yesterday we thought about tables, and we thought about tables with vertical asymptotes? And we saw something weird in our tables. We saw, as we got closer and closer to a vertical asymptote, from the right or from the left, that the numbers would increase without bound or decrease without bound. What's going to be different this time is we have, or if we're thinking about limits numerically, we have to be the one increasing without bound or decreasing without bound. Our x's need to have that same pattern, not our y's necessarily. They might not. So if I was plugging in, just using yesterday's example, could we plug in 30, then 300, then 3,000, then 3, okay, there's way too many blanks. Can I just do dot, dot, dot? We could increase without bound. Now, is there anything magical about 30? No, it just happened to show up yesterday in that function we were doing. We could have done 10, 100, 1,000, 10,000. We could have done 10, 900, 147,000. 1.2 million. I don't know. We could have just gotten bigger and bigger values. But we tend to like patterns, so we go for it. But if that's one version of increasing without bound, aka approaching infinity in a table, what could be a version of decreasing without bound? Yeah. Now careful. Here's something that physics people would need to distinguish. I know. The magnitude is getting bigger, but the value is decreasing. It's going more and more negative. But guys, do you remember how I showed you yesterday what this really is? Horizontal asymptotes, degree test. So could you technically tackle this homework this weekend if you're like, I have more time than I will any of next week?
No.
Yeah, summer pocket. Get out of here, kids. I'll see you later. Alligators. If anybody wants a hash brown on the way out, I'm not even looking. Just don't dip your fingers in the Chick-fil-A sauce. Hash brown, yes. Your fingers, no. No, you should. They're amazing hash browns. I love them. My dad and I go like every Saturday morning. I like grilled, then I get a little bit of chicken. Don't die.
Work. Dentist. It's work. It's dentist though.
It's work. It's
for you. It's dentist.
You should. There's a whole box of them.